Modern software engineering is moving past the use of artificial intelligence as a simple autocomplete engine. Instead of just suggesting the next line of code, these systems are being deployed as independent worker nodes, agents capable of executing entire multi-file workflows. But when you assign complex execution tasks to an AI living inside a standard integrated development environment, the system inevitably degrades. Over the course of a long session, the agent forgets instructions, hallucinates fixes, and eventually fails. The mechanical failure point is context pollution. An IDE floods the large language model's context window with irrelevant data, unsaved buffers, long chat histories, open tabs, and complete JSON schemas for every available tool. This diagram shows an IDE's context meter rapidly filling compared to a clean, minimal terminal. This cognitive overload strips the model of its reasoning quality. The context window is treated as a dumping ground. When it overflows, the agent loses track of the actual goal. Simply buying a larger context window from an AI provider does not solve this problem. A larger context window just allows the IDE to shove more noise into the prompt, guaranteeing cognitive failure over long programming sessions. Reliable autonomy requires a sterile execution environment. To get real work done, developers are abandoning the IDE and returning to the command line. The terminal is the optimal execution layer for artificial intelligence. It is structurally text-native and highly deterministic, two traits that map perfectly to how a large language model actually processes information. Command line interface agents, like Claude Code or Gemini CLI, bypass the limitations of graphical user interfaces. They treat the context window as a scarce resource that must be strictly managed, pulling in only what is absolutely required. Inside an IDE, you have to visually inspect the code to verify an AI's work. Inside a terminal, the structure is rigid and programmatic. The agent can run tests and verify its own work without relying on human eyes. Removing the graphical sidebar changes the functional role of the system. It operates as an independent worker, stringing together atomic shell commands to achieve a specific end state. To execute complex tasks without polluting their memory, CLI agents rely on progressive disclosure. This is a strategic method of loading context only when the agent specifically requests it. Instead of dumping an entire repository up front, agents read hierarchical documents. A root claude.md file establishes global standards, like strict typing. As the agent works down, nested local files merge with these root instructions, dynamically overriding project rules with module-specific logic. The agent only reads full, detailed instruction sets precisely when it encounters a task requiring that specific expertise. Hierarchical context turns the AI into a specialist on demand. It pulls the right tool for the job exactly when needed, consuming minimal tokens while maintaining deep local awareness. Dumping all organizational logic into a single system prompt is a fast way to break an agent. It is a common professional misconception that all rules belong in one giant chat session. To scale these systems, you must separate instructions, skills, and agents. Custom instructions represent your stable, always-on repository norms. They define your coding style, build processes, and preferred testing frameworks. Agent skills are different. They are portable, highly specific capabilities, like a dedicated script for debugging a web application, acting as discrete packets of knowledge.
The custom agent is the orchestrator. It acts as the persona that parses your custom instructions, evaluates the goal, and decides exactly which agent skill to invoke to get the job done. Context is not capability. The instructions ground the system, the skills provide the explicit tools, and the agent orchestrates the execution. This execution architecture relies heavily on the core Unix philosophy, which happens to be the native language of large language models. Because the terminal is entirely text-based, standard streams dictate the workflow. The text output, or standard out, from one shell program seamlessly becomes the standard input for the AI agent. This maps the terminal's autonomous self-healing loop: plan, act, verify, repeat. If verification fails, it returns exit code 1. The agent reads the standard error text stream, understands the technical failure, autonomously rewrites the code, and reruns to achieve exit code 0. Deterministic exit codes create a closed-loop system. The agent relies entirely on program output to measure success, completely eliminating the need for human visual validation. Scaling autonomy across multiple agents introduces significant risk. Left alone, open-ended chat sessions easily devolve into massive token burn and endless failure loops. Frameworks like Crew AI tackle this by enforcing a paradigm of strict role-based orchestration. The goal is to engineer deterministic, production-grade reliability into the workflow. They utilize bounded delegation. This rule dictates that only specific manager agents can assign tasks. It prevents a scenario where worker agents continuously hand tasks back and forth in an endless game of agent ping-pong. You must also implement iteration limits. This configuration snippet highlights a max ITER field, which acts as a hard circuit breaker to cap token usage. If an agent cannot converge on a programmatic solution within a set number of tries, the system forces it to stop. Tools themselves must be guardrailed. When an agent queries a database, the authoritative raw SQL result must bypass the LLM's natural language rephrasing entirely to prevent any risk of hallucination. Scaling multi-agent systems to a production environment requires a trade-off. You must abandon conversational emergence and enforce rigid engineered guardrails. When you zoom out from the local development environment, the ultimate destination for these agents is the fully automated continuous integration and deployment pipeline. The true power of a CLI agent is its ability to operate completely headlessly. It functions as a scriptable binary executing tasks deep within a production pipeline. In a practical enterprise workflow, a developer opens a pull request. A script automatically spins up the CLI agent. The agent reads the code, runs the test suite, fixes any linter errors it finds, and pushes a clean commit autonomously. This level of programmatic pipeline integration is impossible in a traditional code editor. You cannot trigger a graphical sidebar interface using a GitHub action. This technical architecture provides a foundation for reliable autonomy. Hierarchical instructions ground the agent in the environment. Discrete skills provide specific capabilities, and the terminal acts as the deterministic verification loop required for safe execution. The blinking cursor of the terminal has become the primary interface for delegating entire engineering workflows. It provides the structured environment necessary for an agent to move from conversation to autonomous execution.